I'm Mike James, and in this tutorial I'm going to show you how to use the calculator to help solve a graphical problem. We're given this function of x equals e to the x times sine 2x plus 10 for that domain x between 0 and 4. Now part of the graph is given below, and we're told there's an x-intercept at a and also a maximum point at m where x is p and a minimum point at n where x is q. In the first part we have to write down the x-intercept. Now we could try and find the x-intercept at a by putting y is 0 or f of x equals 0 and trying to solve this equation, but it's quite complicated and we don't do it that way. Because it simply says write down the x-coordinate of a, we use the calculator. They expect you to use the calculator because there's only one mark for this part of the question. So I'm going to go into calculator mode, and I'm going to hit home and tab down to the graph, hit enter, and I'm going to enter the function that we're given. So that's e to the power of x. It's important that you hit the right arrow here and then multiply by sine 2x. Now if you type it in, make sure the 2x is in brackets, plus 10, and you can hit the enter button and nothing appears. Well, why has that happened? That's probably because I'm in degrees and not radians, so I'm going to check my settings by going to File, Settings, Document Settings, and Graphs and Geometry. Yes, I'm in degrees, so I'm going to change that to radians. I need to be in radians because the way the function's laid out, e to the x sine 2x, expected to be in radians. And display digits at this point too, it's worth changing this to about float 5, because if you leave it at float 2, your answer will only be to 2 significant figures, and you want your answer to 3 significant figures. So I'm going to take it as float 5 and make this the default. There it is, the graph appears as expected, and I really need to adjust the window settings, and that's quite easy to do because they've drawn the graph for us here, and I can make use of the domain x between 0 and 4. So my y value needs to be between 15 and -5, so I'm going to go to the menu, window settings, window zoom, window settings, and change my minimum x value to -1, say. The x maximum I'm going to make 4, the y minimum -5, and the y maximum 15. That should do the trick. I'm going to click tab to OK and press enter, and there it is. So I can see the graph quite clearly now. Just move this down a bit. And we need to find the x-intercept at this point, so I'm going to hit menu. You could use a trace if you wanted to, but I think this method is better. Go to analyze graph because it tends to be more accurate, and I hit 0 because 0 is the x-intercept, and I get this vertical dashed line, and I move it to the left of where the x-intercept will be, and I press enter for the lower bound, and then I drag it to the right, or use the right arrow button to move it to the right of where the intercept will be, and press enter. And there it is, 2.3074. I can round that to 3 significant figures, 2.31. So there's the answer. You can see it here. That is the x-intercept at the point A. Okay, so I'm going to minimize this, and the next part of the question is to find the value of p and q. Now if you remember, p is the x-coordinate of the maximum point m, and q is the x-coordinate of the minimum point n. So we can find those two values again by using the calculator. And we go into menu, hit analyze graph, this time choose, well, we choose maximum first, and we drag the vertical line, use the left arrow button and the right arrow button, move it to the left of where the maximum value is, and hit the enter key, and drag it to the right of where the maximum value is, hit the enter key for the upper bound, and you can see the value of x is 1.0172, and you can round that to 1.02 to 3 significant figures. So we do the same finally for the minimum value. Menu, analyze graph, minimum this time, and move the vertical line, dash vertical line to the left of the minimum point, which is about there. Press the enter button, drag it to the right of the minimum point, press the enter button, and you can see it's 2.588. So the x value at the minimum point is 2.59 to 3 significant figures. So that was fairly straightforward. That's P and Q. I've written those down in red. Now, part C, it says find the integral between P and Q of f of x dx. So basically, we know P is 1.02 and Q is 2.59, so I'm going to replace P and Q by those two values, and replace f of x by the function itself, e to the x sine 2x plus 10 dx. Now, you could try and integrate this manually, but you won't be able to do it because you haven't covered enough theory to integrate this. So they expect you to use the calculator, and that's what we're going to do. So I'm going to jump back into the calculator, and I need to go to the home button and go to calculator mode and hit menu, down arrow to calculus, hit enter and choose integral. And I simply enter the function that I've got here on the left hand side. So I'm going to drag this over a bit so you can see it. So I'm just going to copy this into here. So the lower limit is 1.02 and the upper limit, well, before the upper limit will be 2.59, and I'm now going to enter the function itself into that box. Now it's e to the power of x. Hit the right arrow button, multiply, hit the multiplication by sine 2x. Don't forget brackets, very important. Plus 10. And finally, go to the last box and put the x in and press enter. And there it is, 9.92057 is the area between those curves in the x-axis, and you can round that to 9.92 to 3 significant figures. Now finally, it says explain why this is not the area of the shaded region. Now if you look at the diagram, what you've actually found here is the sort of area between those two limits, but because part of the curve is beneath the x-axis, this part of the area will be negative, and therefore it is not the area under the curve. To actually find the area between the curve and the x-axis, you'd have to do it in two parts. You'd have to find this area here and then this area here, the smaller area, which will be negative, and take the absolute value and add the two areas together. So the answer that we've got there is actually incorrect. So there's the explanation.